Hello guys, let's prove by partial fraction method that the standard formula for the integral 1 by x plus a squared dx is equals to 1 by a tangent inverse of x by a plus c. And don't try to factorize this in the real world, I just said it. Don't try to if you want to save time, but if you are just doing out of interest and just wanting to do it for a challenge, go ahead, do this in the real world. But I'll tell you, using this hint, we know reality is often disappointing. This is meant to be the Infinity Gauntlet. Hope that's good enough. Of course, this is quote by Thanos. Now, since reality is often disappointing, we have to go into the complex world. So, in the complex world, you can factorize a square plus b square, let's say, as a minus ib into a plus ib, because here do we know this is just a square minus ib whole square, which is a square minus I square into b square. But we know I square is, well, minus 1. So we'll end up with a square minus b, which is a square plus b square. So using that, let's just factorize it in the complex world. Dx. So in the next step, we'll have to separate the bottom two parts, plus x plus ia dx, and I'll be using the cover-up method. So to find the coefficient of this, or to find the value of the numerator, cover this factor, ask yourself how to make this 0. Well, here x has to be equal to ia. So put the value of x in the other factor. So x, so it will be, you have to account for numerator as well. It will be 1 by 2ia. So that is our first value. And similarly, cover this up, ask yourself how to make this 0. X is equals to minus ia. Cover that up, put the value minus ia over here. You'll get 1 by minus 2ia. So minus 1 by 2ia. So from here, simply take 1 by 2ia common, and you'll get this integral minus that integral. But right here we have a 1 by linear equation of value of x. So it is just the simple log natural of x minus ia. If you really want to know why, or do it step by step carefully, you let u equals to this function, dx will be equals to du. You'll have du by u, which is log natural of u, which is that. Similarly, this would be negative minus log natural of x plus ia. Now we can clearly see that the right hand side is real, because this expression is real, but we have a very complex equation in the complex world. But we have to now utilize the fact that this expression, we can put it in terms of either polar or Euler form. Now let's move on to Euler, because we can see that the Euler form contains E. I'll write it right here. Euler form is REI theta. I'll tell you what R and theta is, but focus on E, because there's log natural over here, and log natural and E, when they come together, they cancel each other, thus giving the power back. Now let's say we have a complex number p plus I cube. This R stands for the radius. Now we actually have to put this in the real complex and real world graph, and this part is the real part, which is p. This part is the q part, or the imaginary part, and this is the radius. So radius, using Pythagoras theorem, is just p square plus q square. And here the angle, well, to find the angle, it's theta. It's oh sorry, I think this should be q and that should be p. I apologize, but either way the radius is that, and then the angle is just geometry, tangent inverse of q by p. So for this part right here, but before that, let's put it in Euler form. So for p plus iq, its Euler form will be equals to square root of p square plus q square into e to the power I tangent inverse of q by p. So for this part over here, instead of p we have x, instead of q we have minus e. So just put that in this and that. What you'll get is root x square minus a whole square is just positive a square into e to the power I tangent inverse of q, which is minus a by x. And similarly for this, it's just log natural of root x square plus a square. Radius is same, e to the power I tangent inverse, and instead of minus a, you just have positive a. Wait, these brackets are confusing, but okay. Now you can just split this log into two log naturals. Just the log property, right? Ln AB is equals to ln A plus ln B. Just use that over here. And this may seem very complex and you may be losing your head, but don't worry, you'll regain your head back in this step over here. So this becomes ln root x square plus a square plus the log natural of this part. So as I told earlier, as I told earlier, ln e cancels, giving us the power back. So this is just plus I tangent inverse of minus a by x, but we don't really want the minus inside. So you have to know that the tangent inverse of, let's say, minus y is equals to the minus tangent inverse of y, or simply minus comes outward. So this is minus a by x. If you want to know why, just for now do heat and trial method. There are other proofs out there, easier proofs. And now this just split into two, but distribute the negative as well. So this is negative I tangent inverse of a by x. Now you can see this and that cancels. And right here also these two are the same, so they add. So it is 1 by 2 ia into minus 2i tangent inverse of a by x. 2i cancels, and now we're in the real world. But before that, let me just add plus c outside. This is plus c. So this is minus ia tangent inverse of a by x plus c. Now we can see we have tangent inverse of x by a in the right hand side, but we have tangent inverse of a by x. Let's just use another inverse trigonometric identity. So let's say just we have originally tangent inverse of y. If we add cotangent inverse of y to it, we don't really need bracket, it will be nicely equals to pi by 2. So, and another part, we don't really have cotangent over here, but what we do know that the cotangent is equals to tangent inverse of 1 by y. Now, we have a by x over here, or let's just take it as negative tangent inverse a by x. So, if we put a by x as y, we'll have tangent inverse of a by x plus the tangent inverse of 1 by a by x, which is simply x by a, equals to pi by 2. Now we want minus tangent inverse of a by x. So this is, well, you can just compute it out. Minus tangent inverse of a by x is equals to this minus that. So overall we'll get 1 by a into tangent inverse of x by a minus pi by 2a plus c. But over here, this is just a constant plus another constant. So when they are two together, they just make another constant. So let's C1, 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 C1. So this will be equals to 1 by a tangent inverse of x by a plus c. So in the little corner, there we have it. We have found our right hand side